Hello, very good evening, guys. Welcome to the faculty-driven platform that is Resultant. कैसे हैं आप लोग? How are you all? So today we're gonna practice the theory of machine, a very important topic or subject basically for SSC JEE. So before starting the session, please do let me know whether my audio and video all good, all perfect. One second, let me check from my end also. 1, 2, 3, 5, 6. Okay, so very good evening all of you. Fine, so just like as promised yesterday, I have already given you the schedule. 7 o'clock we'll be having the Super 30 series, where we'll be having the practice session of the most repeated PYQs of the different subjects. And one of the students have told me, sir, please take the production also. So definitely I'll be taking the production at the end, right? So after the complete schedule, and the last class will be from the production. Okay. Hello, Srinu, good evening, very good evening. How are you? All good? Perfect. Thank you for that. So shall we begin without wasting? And there are like total 30 questions, and we'll try to wind up the session in 40-45 minutes. That is our target. Okay, so it's very important that you be consistent for this particular platform, because every day we'll be having some important, interesting, informative information for your exam preparation. Okay, all good? Perfect. So I hope so everyone has subscribed to our Resultant YouTube channel, because in this channel we'll be having the complete understanding, complete content, free content will be delivered for all the students, those who are planning for GATE, ESC, even for SSC, JEE and AE examination. Hello, good evening, Mohammed. Hello, good evening. So have you liked the session? Please do like, because this is the support that you can give me to us, to our Resultant faculty-driven platform. Okay, fine. So I hope so everyone has seen me in the different YouTube channels or different YouTube sessions, right? So today we'll be talking about one of my favorite subject, basically, that is theory of machine. And if you have studied from me, you might have loved this subject, because this is one of the favorite subject from my graduation also. Okay. Chaliye. So shall we begin? I want your thumbs up in the comment section, then only I'll be starting with the first question. All ready? And if you have any doubt now, you can drop me a mail on my Telegram channel, or you can drop me on basically or a Telegram or mail ID. Okay, fine. Something is happening. Okay, all good. 1 second. So why? Let me check. 1 second, guys. All good. Okay. Fine. Ready? All set? Chali. So let's go with the first question. And if you have any technical or any personal issue, right, you can drop me a mail to this mail ID that you're seeing on the top, on the bottom right corner, that is suraj@resultant.in. Okay. So first question on the screen, from the mechanism topic, what is the maximum possible number of instantaneous for an 8-link mechanism? It should be instantaneous center. Chaliye. Quickly. First question on the screen. I hope so everyone will see the first question. I want response from all of you, so that we can have a very good session. Okay. Yes. Srinu, Mohammed, what is the maximum possible number of instantaneous centers? Basically, it should be centers. Okay, for an 8-link mechanism, 15, 28, 30 or 8. Very good, Srinu. Mohammed, yes, 28. Yes, very good, perfect. Very good evening after a long time. Negi, bahut dino baad. And please do share this video to all of your friends, right? Chaliye. So it's a very simple approach. The number of eye centers is equal to n into n minus 1 by 2. And you won't believe this type of question 3 times in the last 4-5 years. I think 3 to 2 times this question has been repeated. Definitely the numbers were different. So put n is equal to 8. If you put n equal to 8, 8 into 7 by 2, that is 28. Option B is a correct answer. Very good. Done. Number of eye centers. कुछ हुआ है. ठीक है. चलिए, next question. The elliptical trammel that you are seeing on the screen, how you can obtain this elliptical trammel? There are 4 links given, right? So we are having, this is a slider, link number 3 is a slider, link number 1 is also a slider, link number 2 is a connecting link, and link number 4 is a slotted plate. Slotted plate. Okay, so you have to tell me which link you have to fix in order to get the elliptical trammel. A very interesting question from the single slider, double slider, or 4-bar mechanism. Can you tell me? This is an example of single, double, or 4-bar. Definitely, because there are 2 sliders. This is an example of the double slider mechanism. So we can surely say in double slider mechanism there are 3 inversions that we can obtain. One is elliptical trammel, Scotch-Yoke mechanism, and the Oldham's coupling. Okay, and how we can get the elliptical trammels? Tell me quickly. कौन से link को fix करने से? Which link need to be fixed in order to get the elliptical trammels? Quickly. Option A, option B, option C, or option D. None of the above won't be there. Okay. Single. No, it's not a single. You can directly see, no, there are 2 sliders. There are 2 sliders, right? So definitely this is not a single slider. This is the example of a double slider mechanism. This is an example of a double slider mechanism, right? Now, in double slider, there are basically 3 number of inversions. Very good, Negi. Yes, tell me the answer, A, B, or C. This is a very easy question. Very easy question, guys. Quickly. Mohammed, Shrinu, Negi. What about the other students? Those who are live, and please do let me know the answers for this. And do share this video to every possible Telegram channel, so that they would also be joining with us. 1 second, let me check. Where is our Telegram channel? Yeah, that's it. ठीक है. A, B, C, or D? B, sir. B, pakka? Sure. Now, if you have confusion like, sir, link number 3 is a slider or slotted plate. If you see, they are saying that by obtained by fixing the link number 4. Link number 4, okay. Obtained by fixing link 1 or link 3. So, 1 and 3 basically means is a slider. 1 and 3, these are nothing but the slider. And we know that how we can get the elliptical trammels? By fixing the slotted plate. When slotted plate is fixed, then only you will be getting the elliptical trammels. So definitely, if you see obtained by fixing the slotted plate or link number 4, so we can go with option C as the correct answer. It should be written slotted plate. Now, if you see, sir, option A and C seems to be same, right? But C is more correct rather than going with option A. Okay, fine. Achha, tell me, if you fix the slider, what kind of inversion you are getting? If I try to revise, in a double slider mechanism, right? If you fix the slotted plate, you are getting what? You are getting the this one, elliptical trammels. Right? And if you fix one of the slider, then can you tell me what kind of inversion you are getting? If you fix one of the slider, what kind of inversion you are getting? You are getting Scotch-Yoke mechanism. Scotch-Yoke mechanism, right? And if you fix the connecting link, then you are getting the Oldham's coupling. Right? Okay, if you try to draw it over here also, this is one slider, this is the connecting link, this is the second slider, and we are having the slotted plate over here. Okay, is this clear? It's very important. Maximum of question it is being expected from unit number 1, that is degree of freedom or inversions from that kind of this one. Okay, very good, perfect. Chali, next question. Very good. How many degrees of freedom does below mechanism have? Very easy problem. I told you degree of freedom, directly they are asking question, that is the Kruseback equation. You have to use the Kruseback's equation. Okay, what is Kruseback's equation? That is degree of freedom is equal to 3 into n minus 1 minus 2j minus h. Quickly tell me what is the degree of freedom for this mechanism given. Tell me what is the number of links that we're having. This is the fixed one and this is the ternary link. So we can say this is link number 1, this is link number 2, this is link number 3, this is 4, this is 5 and this is 6. So n is equal to 6. We are having n is equal to 6. Number of binary joints, this is a binary joint, this is a binary joint, this is a binary joint, this is again a binary joint, this is a binary joint. These two are also binary joints. So we're having 1, 2, 3, 4, 5, 6, 7. J is equal to 7 and there is no higher pair. Place it and tell me what's the answer. Place it in the main equation, that is a Krusebeck equation, and tell me what's the correct answer. 0, 1, 2, 43. 43 kaise? 43 is not even possible. At least in our undergraduate level, diploma level, maybe 43 is not possible. Very good, very good. So place it and be, so it will be 3 into 6 minus 1 is 5 minus 2 into 7 is 14. That is somewhere around 15 minus 14, that is 1. Option B is a correct answer. Option B is a correct answer. Very good. Acha, tell me, if we are having a linkage whose degree of freedom is equal to 1, what do we call that kind of linkage? If there is a linkage whose degree of freedom is equal to 1, we call it as a kinematic chain. And if one of the link in the kinematic chain is being fixed, we call it as a mechanism. Remember, if you are having a linkage, a closed linkage whose degree of freedom equal to 1, we call it as a kinematic chain. And if one of the link, any one of the link is being fixed, then we call that particular kinematic chain to be a mechanism. This proper definition should be clear. Okay, chalo, next question. We'll try to revise the entire subject through question itself. Okay? What are the number of binary and ternary links in this following kinematic chain we are having? Acha, tell me quickly. Yes, Mohammed, Srinu, Negi. Quickly. Quickly. The number of binary and ternary links that we are having in this following kinematic chain. And this kind of question, thoda confusion rehta hai. Students do have this kind of issues. They are asking binary and ternary links. They are not talking about joints. ठीक है? ध्यान रखिएगा. They are asking you only about links. So tell me, how many binary links, how many ternary links in this following kinematic chain? A, B, C or D? Yes, Negi, Mohammed, Srinu, everyone, those who have joined, please do let me know the final correct answer. Quickly. Yes, I want answers from everyone. Done, done. A, B, C or D? अरे सिंपल है ना. देखो, this is a binary link, है ना? This is a binary link. What is a binary link? We are having two endpoints. Ternary link is basically 3 endpoints. So here we are having this as a ternary link. This is the ternary link. So there is one ternary link. So this is not possible. This is not possible. This is not possible. Option C is the correct answer. They're asking about ternary links. They're not talking about joint. This is a binary joint. This is a ternary joint. Okay, but they're asking about links. So if I try to tell you, if a link is having 2 endpoints, this is called as a binary link. Okay, if a link is having 3 endpoints, then we call this as a ternary link. Okay, fine. And if you're having 4 endpoints, this is a single link, right? ये आपका single link है, 4 endpoints, then we call it as a quaternary link. Quaternary link, right? So here we are having, if you try to visualize, this is binary, this is binary, this is binary, binary, binary. So we are having 5 binary link and 1 ternary link. So answer C is the final answer. Is C is the correct answer. Chaliye, next. Done. Can we now proceed? Next question. All good? ठीक है? Do let me know. All good ना? चलिए, next question on the screen. The Whitworth quick return mechanism is an inversion of a 4-bar mechanism, a double slider mechanism, a single slider mechanism, or none of the above. Whitworth, याद आ रहा है कुछ? Anything you are able to recall? This is obtained in which kind of mechanism? Single, double, or 4-bar? A, B, C, or D? This answer should be in a fraction of seconds. If you have studied from me, definitely you might be able to answer this in less than 5 seconds, right? A, B, C or D? Whitworth quick return mechanism is an inversion of option C. Very good, Srinu. Very good. This is an inversion of a single slider crank mechanism. Acha, can you tell me which link need to be fixed? Which link need to be fixed in a single slider? We are having 4 links. Hai na? In a single slider, we are having 4 links. We are having a cylinder, we are having a piston, we are having a cylinder, we are having a piston or a slider, we are having a connecting rod, and we are having a crank. So tell me, among all the 4 links, which link need to be fixed in order to get Whitworth quick return mechanism? The answer for this is you have to fix which link? Cylinder, slider, connecting rod or crank? You have to fix the crank. Okay, when you fix the crank, you are getting the Whitworth quick return mechanism, and Whitworth is also an example of a double crank mechanism. Whitworth is an example of a double crank mechanism because input and output link both are having a complete circular motion. याद आया animation? Are you able to recall the animation? Don't worry, एक animation पे भी I'll be coming up with one of the video where I'll be showing you the different animations of the entire different mechanism in one go. ठीक है, ताकि आपको clear हो जाए, you are able to visualize. चलिए next question. Very good, Negi, Shrinu, Mohammed. चलिए, which of the following is not the inversion of double slider crank mechanism? Which of the following is not the inversion of the double slider crank mechanism? Oldham, pendulum, Scotch-Yoke mechanism, or elliptical trammel? Just now we have seen Oldham's coupling is an example of a double slider. This is not possible. This is not possible. This is also not possible. Option B is the correct answer. This is an example of a single slider mechanism. Single slider mechanism. Okay, and which link need to be fixed? You have to fix the slider. You have to fix the slider, or we can say piston, right? We call it as a bull engine also. Pendulum pump or bull engine. Perfect. Very good. Done. Done. Yes. Chaliye, next question. What is the degree of freedom does this mechanism shown below have? 0, 1, 2, 3. Now this is an interesting one. ये थोड़ा सा interesting है. The reason being, क्यों interesting है? Students do commit mistake over here. But let us try to identify what is the number of links. This is fixed link number 1. This is link number 2. We are having a sliding pair. This is link number 3. This is link number 4, and this is 1. This is a binary joint. This is a sliding pair. Here also we are having a sliding pair, and here we are having a binary joint. So here we are having n is equal to 4, lower pair is equal to 4, because sliding pair is also an example of a lower pair. ठीक है, कोई higher pair नहीं है. h equal to 0. Tell me what is the answer? A, B, C or D? A, B, C or D? Yes, Srinu, Negi, Mohammed, everyone. What is the answer for this? Quickly. A, B, C or D? देखो यहाँ पे confusion होता है. Student do have confusion. देखो, this is an example of a special case. ठीक है, this is an example of a special case because here we are having one redundant degree of motion. याद आया? Which is being denoted by FR. Perfect. Very good, Shiro. Answer is option A. Here we'll be using the equation F is equal to 3n minus 1 minus 2j minus h minus fr. How to recognize that when you have to use the redundant degree of motion? Exactly. Link number 3 is redundant link. Why? Because if you try to fix link 2 and link 4, link number 1 is already being fixed. You try to place your hand on 2 and 4. Link number 3 still is able to move. That means this kind of link is having one redundant degree of motion, and that is also you can visualize that if you try to give input to link number 2. ठीक है, 2 and 3 के बीच में we are having the sliding motion. 3 is not able to transmit the motion to link number 4. So definitely there is 0 degree of freedom. Okay, so from that logic also you can try to understand. So here if you try to place 3 into 4 minus 1 minus 2 into 4 minus 0 minus 1, solve it, you'll be getting 0. This is an example of a structure. This is an example. This is a special case basically where you are not able to transmit the force from one input link to output link. Okay, chaliye, very good. Next question. Next question quickly. What are the number of binary and ternary joints? Now they are asking you about joints. Okay, this is not links. Joint means the where links are having the end-to-end connection. Chaliye. How many binary, how many ternary joints? If you try to visualize, AB is a binary link, got this, and this is the binary joint because two links are connected together. Okay. Now here 3 links are connected together. This is a ternary link, this is a binary link, this is a ternary link, and this is a binary. So 3 binary, we are having 3 binary joint and 2 ternary joints. So option 3, 2, option C is the correct answer. Option C is the correct answer. Clear hai? Clear? 3 binary and 2 ternary joints. 3. Very good. Very good. Very good. ठीक है. Perfect. Next question. Very good, Srinu. Next question. चलिए. If the relative motion between two links is pure sliding, then the relative instantaneous center is not defined at the point of contact, at the point unit distance away from the common normal at the point of sliding, at the infinity on the line perpendicular to the direction of the sliding. Okay, so very easy. आपके पास we are having a slider, ये आपके पास surface है, we are having a pure sliding motion. You have to tell me where will be the instantaneous center. Very easy question. The instant center will be located at infinity. Pure sliding motion है ना, it's an example of a pure translatory motion, or pure translatory motion में omega is equal to 0. That means the center of rotation is at infinity. Option D is the correct answer. Option D is the correct answer. Clear hai? Done. Next question chale. Perfect. Option D is absolutely correct. Next question. Which of the following is an example of a lower pair? Which of the following is an example of a lower pair? Srinu, option A. Option A, no, it's D. It's D, right? Not defined. We are definitely having a I center. Not defined won't be the correct. You will be saying, sir, infinity is not defined, so we have to go with option A. No. Infinity means the distance is too large. The distance is too large, right? The I center will be located at very, very large distance. Chale. Which of the following is an example of a lower pair? Ball and socket, piston and cylinder, cam and follower. Definitely we know that ball and socket where we are having a 3D motion, right? And we are having a surface contact. This is an example of a lower pair. Example, best example is your, we can say the rear view mirror of the bike. The rear view mirror of the bike, you are able to rotate this in complete 360 like this. Na, aise karke. So this is a ball and socket, piston cylinder, definitely a lower pair. Cam and follower will be having a point contact. This is an example of a higher pair. So only A and B is an example lower pair. Option D is the correct answer. Option D is the correct answer. Perfect. Chaliye. Done. हाँ, very good. Done. Chaliye, next. The maximum efficiency of worm and worm wheel system is. What is the formulation to calculate the maximum efficiency of worm and worm wheel? A, B, C or D? Option A, option B, option C or option D? ये तो direct, it's a formula based question. the maximum efficiency for a worm and worm wheel is equal to 1 minus sine of pressure angle divided by 1 plus sine of pressure angle. And here we are having which option? A, B, C. C is the correct. Oh, sorry, phi is your friction angle. Sorry, not pressure angle, friction angle. ठीक है, ऑप्शन सी इज द करेक्ट आंसर. वेरी गुड, डन. ये तो डायरेक्ट फॉर्मूला है, द डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन, एंड वंस ओनली दे हैव आस्क्ड दिस क्वेश्चन. ठीक है, चलिए नेक्स्ट क्वेश्चन. नाउ लेट्स ट्राई टू टेक सम क्वेश्चन फ्रॉम द गियर एंड गियर ट्रेन. Which term defines the surface below the pitch surface of the gear tooth? Which term defines the surface below the pitch surface of the gear tooth? Face of the tooth, flank of the tooth, profile, or pitch circle? Remember one thing, from gears topic you have to study the gear terminology. That is very very important. वहीं से ही 90% of the question from the gears topic is being asked, right? उसके बाद path of contact वाला numerical, that is not even necessary. Mains के लिए that could be necessary, but prelims के लिए not at all important. चलिए, so if you try to recall, याद आ रहा है कुछ? gears, profile, animation, line of contact. देखो, this is the pitch circle, this is the pitch circle, so it will be there. So this is, we can say, this is the face of the tooth and this portion is the flank of the tooth. ठीक है, fine, right? And they are saying the surface below the pitch surface, this is the pitch surface. ये आपका pitch surface है, this is your pitch surface. Pitch surface के नीचे we are having the flank of the tooth. Clear है? Flank of the tooth is present. अगर बोलता what is the surface above the pitch surface, the answer will be face of the tooth. This is your tooth profile. This is your, let me use a different color. This portion is your tooth profile. Okay, pitch circle already I have shown. So all the four options that is available on the screen, I've showed you all the four options. Chaliye, so option B is a correct answer. Done. Chaliye, next question. Which of the following curve is obtained traced by a point on the circumference of the circle which rolls without slipping on a fixed straight line? So we are having a fixed straight line, right? And a circle is rolling without slip over this fixed straight line. So tell me which of the curve will be obtained. याद आया? ये circle मान लीजिए it has reached somewhere around here, then it has reached somewhere around here. If I try to take a point, the locus of that point, this point will be reaching and then over here, and if you try to join, this profile is called as which profile? Cycloidal, involute, pitch circle or addendum circle. Quickly, A, B, C और D. देखो pitch circle तो हो नहीं सकता. They are talking about the curve. देखो तो C और D में से ही होगा. Will be having either C or D. Either C or D. Cycloidal or involute. This is an example of very good cycloidal profile. है ना? Involute में what is happening? Involute में what is there? We are having a fixed circle and a line is rolling without slip. And if you try to take the locus of a point on that line, this is your involute profile. We are having a fixed circle, the line is rolling without slip, and on a fixed line, if the circle is rolling without slip or a disc is rolling without slip, then we can get a cycloidal profile. Very good, very good. Next question. The mass of the flywheel of a steam engine is 3250 kg with a radius of gyration of 1 meter. ठीक है, आपको क्या दे रखा है? मास दे रखा. मास is equal to 3250 kg. The radius of gyration is equal to 1 meter. The torque is equal to 4500 Newton meter. What is the angular? अरे भाई इतना easy, very easy question. What is this? Let us say alpha is your angular acceleration, है ना? How you can calculate? देखो torque दे रखा है m and k, that basically gives you the moment of inertia. So we can directly say tau is equal to I into alpha. जैसे f is equal to mass into acceleration, torque is equal to I into alpha. Torque is given 4500. This is mk square, है ना? This is mk square, that is 3250 into 1 square into alpha. तो यहाँ से alpha is equal to 4500 by 3250. Nearest value कितना है? See the options, 1 point something, it should be somewhere around 1.70, 1.38 is the correct answer. Solve नहीं करना है, रेडियन पर सेकेंड स्क्वायर, ठीक है. You always try to see the nearest value. इतना ज्यादा सॉल्व करेंगे, it won't be इतना समय नहीं होता. We are not having that much of time to invest on one question. 2 hours, 200 questions, है ना. So try to solve as many questions as you can in the first 90 minutes. ठीक है, last 30 minutes you have to see the entire, you have to go through those questions where you have skipped out. हाँ, चलिए, very good, perfect. D option is the correct answer. Next question quickly. The moment of inertia of the flywheel is 19.6 kg meter square and it fluctuates at the speed of 40 rpm. For the fluctuation of energy if 2036 joules, what is the mean speed of the flywheel? हाँ, this is an interesting one. यहाँ पे बहुत students को ना confusion भी आता है. Many students have personally texted me, sir, can you solve this question? So that is the reason I have taken up this problem. चलिए, try this problem. They're asking moment of inertia. Now let us try to write the given data. Moment of inertia I is equal to 19.6 kg meter square. ठीक है. Fluctuation of speed मतलब change in RPM is given, और we can say omega is equal to 2 pi into 40 by 60. We can write this is 8 pi by 6 or 4 pi by 3 radian per second. ठीक है. What is the mean speed? What is the mean speed they're asking? चलिए, try this. कैसे करें? They have given the energy or change in energy or fluctuation of energy is given as 2036 joules. How we can try? Now, change in energy थोड़ा logically देखते हैं. देखो, change in energy is equal to half into I into omega 1 square minus omega 2 square. मतलब omega 1 is omega maximum and omega 2 is omega minimum. We can rewrite this equation as I into omega 1 minus omega 2 into omega 1 plus omega 2 by 2, right? What is this? This is change in omega. This is nothing but mean, है ना. This is nothing but mean. Omega m ले लेते हैं, है ना. Let us take it as omega m, right? So everything is being given. Change in this 2036. I is equal to 19.6. Change in omega is 4 pi by 3 and omega m we have to calculate. ठीक है. So omega m is equal to, let us take it as 20. 4 pi by 3, ये थोड़ा कितना आएगा? This is 1 point something through 4.1 3148. एक बार चेक कीजिए, 4.18 रेडियन पर सेकेंड, this value. So this is 2036 divided by 19.6 into 4.18. So देखो 19.6 से we can take it as 20. अगर मान लीजिए 20 ले लेते हैं तो 100 के राउंड आएगा, 100 से थोड़ा ज्यादा. So 24 के राउंड आना चाहिए, क्योंकि 100 by 4.18 is somewhere less than 25. Less than 25 वाला वैल्यू ऑप्शन ए इज द करेक्ट आंसर. Less than 25, 24.79. वैल्यू आई हैव रिटन बाय सीइंग द ऑप्शन. ठीक है, मैंने कैलकुलेट नहीं किया है, जस्ट गॉन फॉर द रफ कैलकुलेशन, क्योंकि 2036 बाय 19.6 समवेयर अराउंड 100 के राउंड आएगा. 100 बाय 4 इज 25, क्योंकि 4.18 है, शुड बी स्लाइटली लेस देन 25. सो द नियरेस्ट वैल्यू इज 24.7. ऐसे यू हैव टू सॉल्व सम बिग कैलकुलेशन. अगर क्वेश्चन आता है वेयर देयर आर सम कॉम्प्लिकेटेड कैलकुलेशंस, यू हैव टू डू सम अप्रोक्सीमेशन लाइक दिस, तभी आपका क्वेश्चन जल्द ही और सही सॉल्व. क्योंकि व्हाई हैव टेकन दिस, देखो यहाँ पे रेंज इज वेरी लेस. इफ यू ट्राई टू सी 24.79, दूसरा 25, 27, 30, रेंज इज मतलब जो आपका वैल्यूज का जो रेंज है दैट इज वेरी वेरी क्लोज. सो दैट इज द रीजन वी हैव टू ट्राई सम अप्रोक्सीमेटिव कैलकुलेशन. ठीक है, जैसे पिछले वाले में वी आर हैविंग लार्जर रेंज 1.32, 3.4, 2.48. सो डेफिनेटली वी कैन गो विद दैट. ठीक है, चलिए नेक्स्ट क्वेश्चन ऑन द स्क्रीन. When the relation FC is equal to AR plus B is satisfied for a spring controlled governor, a question from the governor topic. The relation between the controlling force and radius of rotation, this type of governor is known as, आपको बताना है, if we are having the controlling force is equal to AR plus B, then this type of spring controlled governor is called stable, unstable, isochronous or hunting. Not hunt, it should be hunting. चलिए quickly remember that graph, straight line वाला graph, if you try to recall, ऐसा था. We are having the controlling force over here, we are having the radius of rotation. ठीक है, एक ऐसे था, एक ऐसे था, and one was like this. ठीक है, this is FC is equal to AR. This is FC is equal to AR plus B, where A and B are constant, okay? And this is your FC is equal to AR minus B. Chaliye, so tell me what is the correct answer? This type of governor where FC is equal to AR plus B is being satisfied. Stable, unstable, isochronous. याद करो, बहुत important है. Governor say, if they're asking question, they could ask question from this. If they're gonna ask you question, they could ask you question from this. Answer for this is definitely unstable. क्योंकि your FC is equal to AR plus B. This is for an unstable governor. ठीक है, FC is equal to AR. This is for isochronous governor, and FC is equal to AR minus B. This is for a stable governor. Remember this, very important. Governor say, if they're asking question, surely 100% it will be from the controlling force diagram. ठीक है, controlling force diagram से ही आएगा अगर पूछे तो, if they're asking. ठीक है, done. Okay, chaliye next question. Now let's try to take some question from the vibration topic. The amplitude of underdamping, a small damping varies with time as linearly, arithmetically, geometrically or exponentially. Quickly, how the amplitude of underdamping, a small damping varies with time? Linear, arithmetic, geometrically or exponentially? A, B, C or D? Quickly, याद करो. देखो, there are three types of damped vibration. We are having over damped, under damped and critically damped, and we know that over damped and critically damped there is no vibration. सिर्फ और सिर्फ we are having in under damping. ठीक है, and under damping में we know that the amplitude of vibration is always varies exponentially. याद करो, देखो ऐसा था ना, 1 second. ठीक है, let me draw that graph so that you are able to recall. This is for under damping. ठीक है, ऐसे तक करो. This is for under damping. ठीक है, fine. And this is your amplitude of vibration, this one, and that is equal to e to the power zeta omega n t d. This was the amplitude, and this is exponentially decreasing. This is exponentially decreasing. Clear है? Done. A minus sign, negatively है ना, negative exponential. ठीक है, negative exponential decreasing. Option D is the correct answer. Clear है? Over damping and your critical damping, there is no vibration. Over damping and critical damping में there is no vibration. So here we are getting option क्या है? D is the correct answer. Very good, Negi. Next question. A mass of 1 kg is attached to the end of the spring with a stiffness of 0.7 Newton per mm. The critical damping coefficient of the system is CC की value they are asking you. They have given you the mass value 1 kg. they have given you the stiffness that is 0.7 in Newton per mm. इसको Newton per meter में convert कर लीजिए, because in the options we are having Newton per meter and there only the students are committing the mistake. So that is equal to 700 Newton per meter. चलिए, now we know that critical damping coefficient is equal to 2m omega n. अब omega n कौन निकाले, कोई जरूरत नहीं है, 2 root k into m. 2 into root of k value is 700, mass is 1, so this is 20 root 7. अब देखो 7 का रूट वैसे तो याद नहीं है, डेफिनेटली 2 और 3 के बीच में होगा. लेट अस टेक 2.5. 2.5 के अराउंड है, तो 2.5 into this will be somewhere around. What is the answer? Quickly. A, B, C or D? A, B, C or D? मास 1 कीजिए, हाँ ठीक है. So correct answer for this is A, 1.4, 18.522, 52 point this, or we are having this one. So it will be somewhere around 2.20 into somewhere around 2.5 something, तो ये हो जाएगा 50 के राउंड, 53 ले लेते हैं, 52.9 न्यूटन सेकेंड पर मीटर. ऑप्शन सी इज द करेक्ट आंसर. ठीक है, ऑप्शन सी इज द करेक्ट आंसर. परफेक्ट, वेरी गुड नेगी. 52.92 न्यूटन सेकेंड पर मीटर इज द फाइनल करेक्ट आंसर. चलिए नेक्स्ट क्वेश्चन. Now let's take some question from the balancing topic also. In reciprocating engines, primary forces are completely balanced, are partially balanced, are balanced by secondary forces, cannot be balanced. याद करो, in reciprocating engines, what we are doing, are we going for complete balancing of primary force or partial balancing of the primary force? If we are doing the complete balancing of the primary force, the problem was there कि आपका perpendicular to the line of stroke there is one unbalanced force being created which is having a huge magnitude. That is the reason we are always preferring the partial balancing. Okay, we are always preferring the partial balancing of the primary unbalanced force. Complete आप नहीं कर सकते. Complete करने से the problem was there. If you try to recall, ये आपका slider, this is connecting rod, ठीक है. Now, if you try to completely balance, if you try to keep mass over here, this is the balanced mass. This is the balanced mass. Now, if you are trying to go with a complete balancing, the problem क्या था? Perpendicular to the line of stroke, we are having one force being created, which is having a very high magnitude. इसलिए we are going with the partial balancing. चलिए next question. When shaking force is transmitted through the spring, the damping becomes detrimental. Detrimental का मतलब harmful. When the ratio of its frequency to the natural frequency is greater than, so they are asking you omega by omega n is greater than what value, so that if you try to increase zeta, your this one increases, your we can say harmful. This is the question. What value? 0.25, 0.51 और this is root 2 ना, 2 नहीं है, root 2 है ये. This is not 2, this is root 2. I'm saying हाँ ठीक है, that root 2 was missing. A, B, C, D. They're asking you if you try to increase the zeta, then it becomes harmful. Then what should be the value of omega by omega n? ये आपका transmissibility ratio वाला concept है. This is a concept from the transmissibility ratio. Remember, transmissibility ratio, that is equal to the force transmitted by the maximum unbalanced force, right? And with this, want this ratio to be as minimum as possible. Okay? And we are making a graph. अगर आपको याद होगा, graph से we are able to understand the logic. This is transmissibility ratio on the y-axis. This is omega by omega, and on the x-axis, ये आपका 1 वैल्यू है. दिस इज योर ओमेगा बाय ओमेगा इज इक्वल टू 1, दैट इज रेजोनेंस कंडीशन. दिस इज रूट 2. ठीक है. इफ यू ट्राई टू प्लॉट द ग्राफ, कुछ ऐसे था ये. दिस इज जीटा इक्वल टू 0. दिस इज जीटा इक्वल टू 0. इफ यू ट्राई टू ड्रॉ अदर वैल्यूज ऑल्सो, let's say this is zeta equal to 0.8. कर्व बना देते हैं, with zeta greater than equal to 1. Now if you try to visualize, क्या हो गया, now if you try to visualize, what has happened is, after when omega by omega n, when omega by omega n is greater than root 2, what is happening? If you try to increase the value of zeta, the E value is decreasing, and that should be the case. Was best condition, if E is equal to 0, that is the best condition. If E value is increasing, that is the worst condition. And if you try to visualize here, after this region, if you're decreasing the value of zeta, your E value is decreasing. Okay. Let me write this one opposite. Yeah, if E value is zeta value is decreasing, the E value is also decreasing. So definitely we can say after root 2, when you're increasing the zeta value, it is becoming detrimental or harmful. क्योंकि इससे पहले क्या हो रहा था, if your zeta value is decreasing, E value is increasing. देखो यहाँ पे E equal to 0 पे we are having the highest value, E equal to 1 में we are having the lowest value. But after this point, after root 2 value, क्या हो रहा है, as you are decreasing the value of zeta, E value is also decreasing, and that is the question being asked. E के value जितना minimum होगा, the less the value, the more good will be for the system after omega by omega n is greater than root 2. इस region के बाद ही we can say zeta decreases, E also decreases. इस region से पहले, before this region, as zeta decreases, E value increases. Okay, fine. So here we are having option D as the correct answer, that is equal to root 2. Next question on the screen. The swaying couple results due to, swaying couple याद है, this is basically due to the partial balancing. This is due to the partial balancing in locomotives. This is due to the partial balancing in the locomotives. The answer is swaying couple result due to the primary disturbing force, the secondary disturbing force, partial balancing. Definitely it is due to the partial balancing of the primary distributing or disturbing force. Hello, good evening mechanical. Partial balancing देखो, they are not clear that partial balancing of what, primary or secondary. ठीक है, ये ऑप्शन सही तभी होता when you are able to have like partial balancing of either primary force or secondary force. ठीक है, so I can surely say swaying couple result due to the primary disturbing force, and that is nothing but your partial balancing of the primary disturbing force. If you try to visualize, देखो, this is the line of action of cylinder number 1. देखो ऐसा होता है, this is line of action of cylinder number 1, this is the line of action of cylinder number 2. ठीक है, और लाइन ऑफ स्ट्रोक कर लेते हैं. दिस इज लाइन ऑफ स्ट्रोक ऑफ सिलेंडर नंबर 1 एंड सिलेंडर नंबर 2. दिस इज सेंटर लाइन. ठीक है, तो प्राइमरी दिस इज द प्राइमरी अनबैलेंस फोर्स, दिस इज द प्राइमरी अनबैलेंस फोर्स. ठीक है, और एंड दिस इज अलोंग द लाइन ऑफ स्ट्रोक, और इसी के वजह से वी आर हैविंग वन स्वेइंग कपल. ठीक है, यह सेंटर लाइन है, दिस इज द सेंटर लाइन. ठीक है, फाइन. सो अगर इसके परपेंडिकुलर होता देन वेयर आंसर विल बी व्हाट, द हैमर ब्लो, है ना, याद आया. इफ दिस वाज परपेंडिकुलर टू द लाइन ऑफ स्ट्रोक, परपेंडिकुलर टू लाइन ऑफ स्ट्रोक, वी आर गेटिंग द हैमर ब्लो. ये सब छोटे छोटे की पॉइंट्स है दैट यू हैव टू रिमेंबर, एंड दिस इज ऑल बिकॉज ऑफ द प्राइमरी डिस्टर्बिंग फोर्स. दिस ऑल बिकॉज ऑफ द प्राइमरी डिस्टर्बिंग फोर्स. ठीक है, clear. So option A is more correct, and JEE में you have to make sure इस type के confusions होते हैं, इससे confusing problems are do happening. ठीक है, so that is the reason you have to select the most accurate answer. चलिए next question. Secondary forces in reciprocating mass on engine frames are of same frequency as of the primary force, twice the frequency of the primary force, 4 times the frequency of the primary force, half the frequency of the primary forces. A, B, C or D. primary or secondary force ka, if you try to remember the formulation, that is you are able to recall the solution for that. Chaliye quickly, A, B, C or D. A, B, C or D. देखो, primary unbalanced force is equal to mr omega square cos theta. यही था. What was secondary unbalanced force formulation? The secondary unbalanced force formulation was mr omega square cos 2 theta by n, where n was the obligatory ratio, right? Acha, we can rewrite this equation mr by 4n into 2 omega whole square into cos of 2 theta. Now, if I try to compare secondary and primary, clearly पता चल रहा है secondary unbalanced force is having twice the frequency as that of primary. So option B is a correct answer. ठीक है, देखो यहाँ पे 2 times omega है, we are having only omega. Here we are having only omega. Half नहीं है. We can say primary unbalanced force is equal to 2 times the frequency of secondary unbalanced force. ठीक है, 2 times हो गया ना. Compare the two equations, secondary and primary. Mass same है, radius भी आपका कम हो गया. There we are having r only, there we are having r by 4n. There we are having omega square, here we are having 2 times of omega. ठीक है, so 2 times the frequency of the primary forces. Option B is the correct answer. Very good. ठीक है, comparing करना है, compare, you have to compare the equation. It will be primary unbalanced force is equal to mr omega square cos theta. Secondary unbalanced force is equal to m r by 4n 2 omega whole square cos of 2 theta. ठीक है, तो 2 times omega it is being obtained. चलिए, next question on the screen. I hope so this is clear. In gear drive, the module is equal to, in gear drive, module is equal to 1 upon diametrical pitch, 1 upon circular pitch by pi, diametrical pitch by pi. A, B, C or D. देखो, what is module? Module is equal to the pitch circular diameter by number of teeth in mm. है ना, mm में we are usually, the SI unit for module is in mm. ठीक है. What is the circular pitch? That is pi d by t, right? What is diametrical pitch? Diametrical pitch is t by d, but the diameter is in inches. ठीक है, fine. Diametrical your pitch is in inch. Now, many students will be having a confusion. Let us try to mark option A. Units में क्या रखा है? But अगर if option C was not there, we can directly go with option A, right? But because they have given the option C, that is circular pitch by pi, PC by pi. What is PC by pi? That is pi d by d, that is d by t, and that is your module. So we will be going with option C as a correct answer, not D. Many coaching materials, they have given option A, which is incorrect. Logically option C is correct. ठीक है, diametrical pitch and module, they are not at all same, they are having a difference in unit. ठीक है, fine. 1 upon circular pitch क्या होगा बेटा? देखो, this will be t by pi d, which is not possible. They are asking you in module now, that is d by t. Clear? Option C is a correct answer. Very good. Very good, Negi. Mechanical world done. Perfect. चलिए next question. Next question. Can we go with the next problem? 30 question करना है. Which of the following statement regarding meter gear is correct? Meter gear याद करो. In bevel gear, we have studied the meter gear. These are employed for minimum backlash, great speed reduction, equal speed or minimal axial thrust. The meter gears are provided. Why we are providing the meter gears? Because we need to transmit the power perpendicular and that to same RPM. याद आया? Option C ऐसे था. This is your bevel gear. ठीक है, this is your second bevel gear, right? And it is having rotation from this one to this one, and this is your meter gear. Why we are seeing this meter gear? Because here we are having, let's suppose, t number of teeth. Here also we will be having same number of teeth. Same number of teeth will be present. Same number of teeth. Agar same number of teeth hai, then we'll be having the equal RPM or equal speed. Only the direction is being changed. Perpendicular, it is being transmitted इस axis से we are shifting to this axis. And usually कहाँ इसको देखा जाता है? Best example of meter gear is we are using in the governor. In governor we are using this meter gear. If you have seen in the labs, like let us suppose in the colleges, IC engine lab में when they are opening the engine, there you might have seen governor में meter gear लगा होता है. Okay, so here we are having equal speed. नहीं देखा, don't worry, I'll be coming up with some real life images so as to understand what is meter gear. ठीक है, done. Next question. Which kind of pair can attachment of a car mirror be classified into? Car mirror, rolling pair, sliding pair, spherical pair or screw pair? कोई भी doubt नहीं होना चाहिए because already we have taken up this question in different format. Which kind of pair can be obtained in a car mirror? Rolling, sliding, spherical or screw pair? A, B, C or D? A, B, C or D? Definitely answer is spherical pair. Because car mirror, we are having something like this. Let's say this is the car mirror. Okay. This one, something like this. So it is able to rotate like this. So this is an example of a spherical pair. Very good. We also call it as ball and socket joint. Ball and socket joint. Chali, next question. What is the degree of freedom for this mechanism shown below? Count the number of links, count the number of lower pairs. There is no higher pair. Cruise-back equation you have to apply. F is equal to 3n minus 1 minus 2j minus h. H is directly equal to 0. Number of links, try to count it. Number of lower pairs, count kijiye and tell me the answer. 0, 1, 2, 3. 0, 1, 2, 3. Quickly. 0, 1, 2, 3. 0 to ho nahi sakta, hai na? So let us try to count the number of links over here. So this is link number 1. This is link number 2. This is 3, this is 4, this slider is link number 5 and this is again 1. So they are having a binary joint, binary joint, binary joint. Here we are having a binary joint and between 5 and 1 we are having a sliding pair, and sliding pair is also example of a lower pair. So how many joints we are having? 1, 2, 3, 4, 5. Number of links is equal to 5. है ना? ठीक है, देखो this is 1 and 2 के बीच में, this is 2 and 3 के बीच में, this is 3 and 4 के बीच में, this is 4 and 5 के बीच में, and between 5 and 1 we are having a sliding pair, right? So we can say 3 into 5 minus 1 minus 2 into 5 minus 0. So this is 12 minus 10, that is equal to 2. Degree of freedom is equal to option C is the correct answer. कोई doubt है? Please do clarify your doubt. Please do clarify your doubt. Any point, if you're having any doubt, do let me know. If you try to visualize, now there's a slider, there are 3 links basically present. We're having link number 5, link number 4 and link number 1 all connected together. Okay? So definitely there is an example of a ternary joint, and one ternary joint is equivalent to 2 binary joint. ऐसे भी सोच सकते हो. Or individually you can calculate, there are there we are having 2 binary joints, one between 4 and 5 the turning pair, and between 5 and 1 we are having the sliding pair. ठीक है? Very good, very good. Option C is the correct answer. चलिए next question. What are the number of binary and ternary links in this following chain? इस following chain में what are the number of binary and ternary links? Binary and ternary links they are asking. Quickly. Binary and ternary links. Quickly. चलिए, let's try. देखो, there are 2 ternary links. This is the ternary link. This is a ternary. Say there are 2 ternary links. That is quite sure. There are 2 ternary links. So let us try to eliminate some options. So A and B तो नहीं हो सकता. Let's try between C and D. What is the answer? Between C and D, what is the answer? देखो, this is a binary link. This is a binary link. This is a binary. Any other binary link that we're having? Any other binary link that we are having apart from this? Yes, we do have. ये देखिए ना. This is also a binary link. So we are having 4 binary links. So 4 and 2, option D is the correct answer. 4 binary and 2 ternary links is the final. They are asking about ternary links. Joint की बात नहीं कर रहा. अगर ये joint बोलता, then we are having this as a binary joint, binary, all are binary joint. All the joints are binary, but they are talking about links. So binary and ternary links में you have to understand the difference. ठीक है? Done. Option D is the correct answer. चलिए next, third last question I think so. How many degrees of freedom exist in a free body in space? If you're having a free body in a 3-dimensional space, then what will be the degree of freedom? X, Y and Z. 3 axis में if a body is being kept, then what will be the degree of freedom? इसको ना ऐसे रखते हैं. X, Y and Z. If you're having a body kept in a 3D space, then how many degree of freedom? If you are having no restriction or constraint, the body is able to translate along X, translate along Y, translate along Z, rotate about X, rotate about Y and rotate about Z. So we are having 6 degrees of freedom, that is 3 translatory and 3 rotational. So option D is the correct answer. I hope so this you know. कोई भी body अगर 3D space में रखते हैं, we are having 6 basic degrees of freedom, that is 3 translatory motion and 3 rotational motion. Option D, 6 is the correct answer. Clear है? Done. Option D, 6 is the final correct answer. Okay. 2 more questions left out. जल्दी से करते हैं and let's try to wind up the session. Done. Next question on the screen. I hope so this is quite clear. Option D, 6 is the correct answer. Which of the following is a gravity controlled type governor? Gravity classification of governor से question है. Which of the following is an example of a gravity controlled type governor? Hartnell, Hartung, Watt governor or Pickering governor? Yes. Which is an example of a gravity controlled type? Option C. Watt governor. These all are the example of the spring controlled governor. This one and this one. This is an example of the spring controlled governor. ठीक है? Clear? I hope so you are able to recall everything. हो सकता है you are not able to recall quickly, but after this session you are having a complete revision of this subject, that is theory of machine. I can surely say इस session के बाद you will be in a very good position where you will be able to solve all the question from theory of machine in the examination जो आपका next first week of June में होने वाला है. That I can surely say because I have kept that each and every topic of the theory of machine subject is being covered. ठीक है? I have make sure that every individual unit is being at least 1 or 2 question I have taken from each and every subtopics. चलिए, option C, what governor is the final correct answer. Last question on the screen. Last question on the screen. Which of the following relation is correct about the controlling force F and the spring control? This is question being repeated. You can clearly see might be the way they are asking different, but the logic the same. We have already solved one question from this topic previously, and this way they are asking the same logical question again and again in the examination. A, B, C or D. Which of the following is telling us about for a stable governor? देखो option A तो unstable के लिए है. Option B, definitely this is for a stable governor. Option C, is for an isochronous governor. And option D, कुछ नहीं है, ऐसा कुछ होता नहीं है. Okay, so we are having option B is the final correct answer. This was the 30th question of today's session, and we have completed this today's 30 most repeated PYQs from the theory of machine. So today's end is this, and we have we can say covered this one. Now we have to go with the heat transfer, then fluid mechanics, thermal application, and right. So definitely पहला सेशन हो चुका है. Now we'll meeting on 24th, not tomorrow, 2 दिन बाद, 3 दिन बाद basically. We'll meeting on 24th May. We'll be discussing heat transfer, and from 24th onwards we'll be having the regular sessions daily. They go 24, 25, 26, 27, 28 ko we'll be having the production wala I told you, na? So don't worry about that. Okay, so this is for today's session. I hope so you all enjoyed in our resultant platform, and definitely you have to subscribe to our channel so that you are updated whenever any session is being planned. You are first one to get notified. So make sure you have all subscribed to this channel, and please like this video and share this video to all of your friends, or those who are seeing this in the recorded session. Please try to solve each and every question, because every question is important. Okay, fine. So thank you all of you for joining with me on this resultant platform that is faculty driven, and let's see you on 24th May at 7 p.m. and we'll be having the heat transfer subject will be discussed. Okay, any doubt you can do drop me a mail, और कोई भी दिक्कत होता है I'm there to help you out. You have my Telegram channel also. Okay, thank you guys, bye bye, take care, stay safe, and enjoy your preparations with us resultant. Like करना मत भूलिएगा, share this video, subscribe to this channel. Thank you, bye bye.